So we're up to balanced and unbalanced forces. So here we have a rock, and that rock is held up by a piece of string. We know that the rock has a force due to gravity acting on it, and in this case, let's say that is 10 newtons down. The string also supplies a force, which we call a tension force, of 10 newtons up. So in this case, we say that the forces are balanced because they have the same magnitude or same size, and they're opposite in direction. So the effect of one of those forces is balanced by the effect of the other force. So in this case, the rock's motion will not change because the forces are balanced. Now we can actually do a mathematical sum on that and say that the net force, which is another way of saying the total force, which equals the sum of all forces, equals 10 newtons down plus 10 newtons up, which in this case is 0 newtons because down and up are opposite. Again, the forces are balanced, the rock will not change its motion. Let's have a look at the rock again. We've still got force due to gravity 10 newtons down, but this time we're going to cut the string. So there's no string holding it. Gravity is the only force, and that force is now unbalanced. There is no tension force acting up to balance that force due to gravity. So in this case, the rock's motion will change, and we know that the rock will now fall down. Let's have a look at this in a different situation. We've got a car here, and there are four main forces acting on this car. We have gravity, which is acting down. We have the normal force, which is the road pushing up on the car. And those two forces are equal in size and opposite in direction. They're balanced. We also have a driving force, which is moving the car forward, and friction forces, which are trying to pull the car backwards. And again, these two forces are equal in size and opposite in direction. So we say that all of those forces are balanced. But let's have a look at the situation again. The force due to gravity down, the normal force acting up have not changed. The driving force has not changed, but in this situation, the friction force is a lot smaller than the driving force. So we now have unbalanced forces. Let's take away the force due to gravity and the normal force from this situation and just have a look at the driving force and the friction forces. We can see that even though they're acting in opposite directions, they have a different size. So we can actually add those two forces together, and what we get is something called a net force. And in this case, because the driving force was larger than the friction force, the net force is acting in the forwards direction for this car, and the motion of the car is going to change. This car is going to accelerate in the forwards direction. So, to sum that up, balanced forces is just a simple way of saying we have two forces that are of the same magnitude, which means the same size, but are acting in opposite direction. And unbalanced forces is every other situation.